Good morning. Let's do a recap of what we did in the last class. So we said that an atom can be represented in two ways. One of them is electron configuration. The other one is either using dots or crosses. So we did the first one, electron configuration. So the question is, what does electron configuration entail? It simply means the way we distribute electrons in the shells, okay? And for the sake of new students, so we have an atom, okay? And we said atoms are very small particles. They are very small particles. Then we have what we call elements, okay, or an element found in the periodic table. So for every element, if we take an example of sodium, which is an element, it is made up of many atoms. Okay, an atom is very small, but it has subatomic particles. It has other particles. We have protons, we have the neutrons and electrons. Protons are positively charged, the neutrons have no charge, electrons are negatively charged. So let's move on. Ways in which we can represent the atomic structure of an atom. So one is electronic configuration and the second one using dots or crosses. So let's do number one. Electronic configuration simply means how are electrons distributed in the shells. I want us to take the first example, which is sodium. And sodium is atomic number 11. If sodium is atomic number 11, remember we said atomic number is the number of protons in an atom. And we also mentioned that for every atom, the number of protons and electrons are the same. And even from the word electronic configuration, it means we really need to know the electrons. So the number of protons and electrons are the same. So sodium has 11 protons and 11 electrons. But remember, how do we distribute electrons in the shells? So we have to remember the rules. It says the first shell has 2 electrons, okay, takes 2 electrons. The second shell takes 8. The third shell takes 8 electrons. And the fourth shell takes the remainder, okay? So that means taking 8 if an atom has 8. If you put 2 electrons in the first shell, then you realize you only have 4 electrons remaining, then you put the 4 electrons in the second shell. So 8 is the maximum number of electrons that you can put in that shell, meaning that you can have less electrons. The third shell, the maximum is 8, meaning you can have less than 8. So let's take our first example, sodium. So the first shell takes 2 electrons. We have that. It takes 2 electrons. Then we go to the second shell, takes 8 electrons. So far we have filled how many electrons? 10. 8 plus 2 is 10. But remember, sodium has 11. So it means we have one more electron remaining. We put the 1 electron in the third shell. Remember what I have said? The third shell takes 8. 8 is the maximum, meaning we can have less than 8. Okay? Good job. Let's go to example number 2. Let's take an example of potassium, atomic number 19. So it means we have 19 protons and 19 electrons. So electron configuration, the first shell takes how many electrons? It takes 2. The second shell takes 8. Okay? And remember we have 19 electrons that we need to distribute in the shells. So far we have 10, meaning we still have 9 more electrons, meaning that the third shell can take 8. So 8 plus 2 is 10, plus 8, 18. So we have one more electron. We put the one more electron in the fourth shell. And that's why I have indicated that in the fourth shell, you put the remainder. Remember, we will only deal with the first 20 elements. The first 20 elements. Okay, so we have 2, 8, 8, 1. So the first shell takes 2, the second takes 2, 8, sorry, the third 8. So 8, 8 is the maximum. It can take less than that. Let's take another example of beryllium. So beryllium is atomic number 4. Okay, atomic number 4 means it has how many protons? 4, electrons 4. And so what will be the electron configuration? Go back to the first shell. We have said the first shell takes how many electrons? 2. So once you put 2, and remember total electrons is 4, it means you have 2 more electrons. So you put the 2 electrons in the second shell. And that's why I said that the second shell taking 8 electrons, 8 is the maximum. 8 is the maximum. It can take less than that. I hope that concept was very clear. Then let's move on to the second way on how we can be able to represent the atomic structure. So we can use dots or crosses. Let's go to, we use the same examples, sodium. So remember we found out that the electron configuration for sodium will be 281 because it has 11 electrons. So using dots or crosses means you draw your atom. Okay, so this is the atomic structure, and then in the middle you have your nucleus. So this is my nucleus here. And what is Na? Na is the symbol for sodium. And remember in the last lesson we said, why are we having Na as the chemical symbol for sodium? Because we derive the chemical symbol from the Latin name natrium, and therefore we have Na. So in the nucleus, you put the chemical symbol. So you can either put the chemical symbol, or if you know the number of protons, so in the middle, you write how many protons you have and how many neutrons you have. But if you don't have that information, you just write the chemical symbol in the middle. So I have my nucleus, and then once you have your nucleus and you have the chemical symbol for that element, you move on and have your first shell. Okay, so 281 means we will have 3 shells. So the first shell takes 2 electrons. So this is my first electron in the first shell, and this is my second electron. So I have 2 electrons in my first shell. Then what about the second shell? The second shell has 8 electrons. Then for your work to be organized, it is good you pair up the electrons. So I have 1, 2 in the second shell. 1, 2, then I have 3, 4, 5, 6, 7, 8. So my second shell has 8 electrons. And what about my last shell? My last shell has 1 electron. And that's why we have 281. So can you see there is a relationship between using dots or crosses and electronic configuration? Yes. If you know the electron configuration, it's so easy to write this now to represent this in a drawing. Okay, very good. Let's go very fast to our second example where we have potassium. Remember the electron configuration was 2881. So this means potassium has 4 shells. So we have 1, 2, 3, and 4. Higher. When you come to your element there you want to draw, remember in the middle, what do we have? The nucleus. Again, potassium. Why do we have K as the chemical symbol? This is because we derive the chemical symbol of potassium from its Latin name, which is kalium. So we have K is the chemical symbol for potassium. So once I have my nucleus, I move to the first shell. How many electrons do I have in the first shell? 2. So I put my 1 there and this other one down here. Then my second shell has 8 electrons. I have said it looks beautiful if you can pair electrons. So 1, 2, 3, 4, 5, 6, 7, 8. Then you move on to the third shell. The third shell has 8 electrons. Put them 1, 2, 3, 4, 5, 6, 7, 8. Then the fourth shell has how many? 1 electron. That's what we have. Very fast, the last one, beryllium. The electron configuration was 2, 2. So have your nucleus. I have my nucleus ready with the chemical symbol for beryllium, which is Be. And then I move on to my first shell. My first shell has how many electrons? It has 2. So I put 1 and 2. And also I go to the second shell and put 1 and 2. Can you see in beryllium, the second shell has taken 2 electrons? That's why I said that when we say the second shell and the third shell are taking 8 electrons, those are maximum. It can take less than 8. Okay? Less than 8. So I hope you got the concept right. Just in case you still have a problem, let me know. Thanks for watching.